This is number 68 in chapter 17. It asks us to consider the following equilibria reaction. We have carbon dioxide plus carbon tetrachloride is in equilibrium with two COCl2s, or oxyl chlorides, as a gas. And it asks us what is the delta G for this process at 25 degrees Celsius if we have a pressure of our CO2 equal to 0.112 atmospheres. We have a pressure of our carbon tetrachloride equal to 0.174 atmospheres. And we have a pressure of our COCl2 equal to 0.744 atmospheres. So those are our pressures, and we're trying to figure out our delta G. And so since these aren't equilibrium pressures, that's why we're talking about a delta G that's not at standard state, so we don't have that little circle. So we want to use this expression. Our delta G not at standard state is equal to our delta G at standard state plus RT times the natural log of Q. So the first step is to figure out our delta G, and then we actually now have all the information to solve the question. And so remember, our delta G for a reaction is going to be just the sum of those delta G's of formation for our products minus the sum of those delta G of formations for our starting material. And so we need to go to the tables to look up these values. And so the delta G of the reaction would be equal to our delta G for COCl2 as a gas, and we would need to take 2 times that based on our stoichiometry. We then subtract off from that our starting materials, which would be the delta G for our CO2 as a gas plus the delta G for formation of our carbon tetrachloride as a gas. And so if we substitute in those values, we would have 2 times a negative 204.9 minus then the sum of negative 394.4 plus negative 62.3. And so if we sum all of that up, we get a delta G of reaction at standard state equal to 46.9 kilojoules per mole. So that is our delta G, simply looking at the difference in Gibbs free energy of formation of our products minus our starting materials. And so we're going to plug that value into that delta G expression. So if we take that delta G expression just a little bit further, right, we know what that Q is, right? It's going to be the pressure of our COCl2 squared over the pressure of our carbon dioxide times the pressure of our carbon tetrachloride. And so we have all of these values given from the question. We just solved for our delta G at standard state, and so we can plug these values in. We have a 46.9 kilojoules per mole for our delta G. We have our R value. I'm going to already convert it to kilojoules per mole Kelvin, so it agrees with our kilojoules per mole for our delta G. Our temperature was 298, and then that will be times the log of our 0.744 squared over our 0.112 times our 0.174. Apologize for running that into that. We solve these guys, we would have our 46.9 plus 2.477. That's the product of R and 298 times the natural log of 28.403. That 28.403 is that ratio of pressures for our Q. And so that delta G is going to be 46.9 plus 8.289 to give us a final value of 55.18 kilojoules per mole for this delta G that's not at standard state. And since it's a positive delta G, that would indicate that the equilibrium would be shifting to the left or the starting material side to reach equilibrium. That is number 68 in chapter 17.